Dear students, progressions, class 10, prepared by me, V. Nagaraju, JPH Saliabad. Now students, let us see some numerical patterns 11, 17, 23, 29 up to so on. So here the difference between 17 and 11 is 6, and also you can observe it as 23 and 17 is also 6. Here again 29 and 23, difference of 29 and 23 is also a 6. So by observing this pattern, here the 17 is increased by 6 and 23 and 29 also increased by a constant term, that is 6. And next see that next pattern 4, 8, 12, 16 up to so on. And here also the difference of the 8 and 4 is simply 4. 12 and 8 is also 4. 16 and 12 is also 4 up to so on. So then next let us see this picture. The first picture we have 3 rectangles and then 2 more on that 3 rectangles, that is we have 5 rectangles and then 7 rectangles. Here also 2 is increased by the first term, that is here 3 is first number and 5 is the second number, and 5 is increased by 2 and 7 is also increased by 5. And next in this also, in this pattern also we have the first figure we have 3 mastics, and next figure 5 mastics, and in next 7 mastics, in the last 9 mastics. So this is also followed by a particular pattern. Okay, now so what is the progression? Students, in lower classes you already know about some patterns. Now let us see some examples. 2, 4, 6, 8 up to so on. So what is the next number followed by 8? So yes, it is 10, and next 12, 14 up to so on. So by observing first 3 or 4 terms, we can easily say the next term followed by the 8. And next 3, 6, 9, 12 up to so on. So can you think what is the number followed by 12? Yes, it is definitely 15, and next 18, 21 up to so on. Now some examples of our daily life. I am taking one job holder situation. Usha applied for a job and got selected. She has been offered a job with a starting monthly salary of 8,000 with an annual increment of 500. So her salary for to first, second, third up to so on 30 years will be 8,000, 8,500, 9,000 up to so on respectively. That means here the first year's salary for every month is 8,000. So here annual increment is how much? 500. So we should add 500 to the top of the 8,000 to get the successive year salary, that is the next year's salary. And next, to get the third year salary, we have to add 500 to the top of the 8,500. And next, one more. The length of the rungs of a ladder decrease uniformly by 2 cm from bottom to top. The bottom rung is 45 cm in length. The lengths of the 1, 2, 3 up to so on, the rungs from the bottom to the top are as usually 45, 43, 41, so up to so on 31 respectively. So here again 45 and 43, the difference of these two is simply 2. That means the 43 is less than to that of the 45. Okay. Now, can you see any relation between the terms in the pattern of the numbers written above? So, think over it. Now, we have to try to find pattern in the example 1 and example 2. So, the relation between the numbers in each list is constantly progressive. Constantly progressive means the 8,000, 8,500, 9,000 are simply increased by a constant number, that is 500. So in the given list 8,000, 8,500, 9,000, each succeeding term is obtained by adding 500 to the preceding term. So here by seeing 8,000 and 8,500, we can say 8,500 is succeeding to 8,000. Then with respect to 8,500, 8,000 is preceding one. So that's why to get 8,500, we have to add 500 to the preceding number 8,000. So as to get 8,500. And similarly, to get 9,000, we have to add the constant 500 number to the previous number 8,500. Now, in the second example, whereas in 45, 43, 41 up to so on, each succeeding term is obtained by adding minus to preceding term. So here we are subtracting, but we are used here sign minus to the 2. So that's why it is gradually decreased by 2. Okay, and next. Now we can see some more examples of progressive pattern. The number of unit squares with sides 1, 2, 3 up to so on units are respectively 1 square, 2 square, 3 square up to so on. So here 1, 2, 3 are the first units, and then to get their squares we have to write 1 square, 2 square, 3 square up to so on. Now geometrically we can see first one 1 square, second one, third one 2 square and 3 square. Okay, so this is for understanding the pattern. Okay, next. Now one more live example. Hema put ₹1,000 into her daughter's money box when she was 1 year old and increased the amount by ₹500 every year. That means Hema gives a gift for every year to his daughter, or she wants to save some money for his daughter for the sake of her daughter. So first he saves ₹1,000, and then for every year she added 500. Okay, now the amount of money in the box on her first, second, third, fourth up to so on birthday would be, we can say easily 1,000, 1,500, 2,000, 2,500 up to so on respectively. Okay, children, see this, particularly this example, very interesting, and you can easily understand how to write that successive terms. Okay, next. In the examples above, we observe some patterns. In some of them, we find that the succeeding terms are obtained by adding or subtracting a fixed number. In another, we find that they are squares of the consecutive number, and so on. That means here that Hema's daughter birthday situation and that square situation. We have seen two examples there. So once again reading here, see that the succeeding terms are obtained by adding or subtracting a fixed number. Okay, that adding a fixed number is example of that Hema's daughter's birthday, and the next subtracting fixed number is the ladder's sum. So by observing those two, we may add or subtract to get the successive terms. So if we find that they are some another example, we find that they are squares of consecutive numbers and so on. So already we seen geometrically 1 square, 2 square, 3 square up to so on. For 1 square we got only 1 square, for 2 square we got 4 squares, and for 3 square we got 9 squares. So like that. Now in this chapter we shall discuss some of these patterns in which succeeding terms are obtained by adding a fixed number to the preceding terms, or in some cases multiplying preceding terms by a fixed number. Now we shall also see how to find the nth term and sum of n consecutive terms and use this knowledge in solving some daily life problems. Okay, now learning objectives in this section: definition of arithmetic progression and common difference. We are going to be learning how to verify the given situation forms an arithmetic progression, and how to write terms in the arithmetic progression whenever first term and common difference are given. So now let us see what is an arithmetic progression. Now we observe the arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Children, I am once again reading this definition. Just try to understand this one once again. We observed that arithmetic progression is a list of numbers. Already we observed so many examples. In that list of numbers, what we observed, each term is obtained by adding a fixed number to the preceding term except the first term. So in that Emma's daughter's example, what we take 1000, 1500, 2000 up to so on. So her mother first saved 1000 rupees for our first birthday. The next birthdays she is added 500 for every year. That means 500 is added to that of the first 1000. That is 1000 into 500, 1500. That is for her second birthday. And again 1500 plus 500. That is for her third birthday. Like that we are getting that progressive pattern. So that's why it is known as a arithmetic progression. Why? Because we are adding here, adding and subtracting we are taking here. That's why it is known as a arithmetic progression. Okay, now I think you get a clear cut idea on this arithmetic progression. Now this fixed number is called the common difference of the AP. Whatever we are adding that particular number, that is known as a fixed number. And in this AP, this fixed number is generally known as common difference. It is denoted by T. So let us see that one. Let us denote the first term of an AP by A1, second term by A2, up to so on, nth term by AN. So children, here see that the terms are denoted by that A and subsequent one, and the second term is A by subsequent 2. That is, we are using the first term notation as A1 and second term notation as A2, and up to so on, nth term notation is AN. Okay, so generally the common difference by D. Then the AP becomes A1, A2, A3, up to so on AN. So simply we can say A2 minus A1 is equal to A3 minus A2 is equal to up to so on AN minus 1 is equal to D. So see children, here in the first example to the last example, we are observing this point only. So the given pattern or the given list of numbers, whether they followed the AP rule, that is arithmetic progression rule or not, we have to verify the differences of the successive terms. That means A2 minus A1 and then A3 minus A2. If both are equal, we can say that progression that given list forms a arithmetic progression. So, and again we can I can explain in detail in further videos also. Okay.